like to welcome you to this symposium. I'm Matt O'Donnell. I'm the Dean of Engineering here at the University of Washington. I think it's totally appropriate that you get a bio guide to introduce an energy conference. And I think the reason why I say that is because what is happening in the energy field, I think, parallels a lot of what we saw a generation ago in the biofield, and that is people speaking a lot of different kinds of languages are actually going to have to talk to each other to make things work. And this is what we hope we're going to see today. We're going to see people from power side, but people involved in energy systems on the IT side is very important. People being involved in this from human factors side, human use side is very important. And so we're seeing a real evolution of this area. And I hope that this symposium represents a start of that dialogue in the state of Washington. We're happy to have representatives from the two research universities, UW and WSU, as well as our major partner, PNNL. And before I'm going to hand it off to Candace from WSU, I want to leave you with one thought. This is what my exposure to this field of the last 3 years or so has been how the evolution of how technology gets used in the marketplace in energy is very, very different than what we're used to in our other two primary sectors, which are bio and information. And the major difference is the need, and I should say the size of sort of second round funding, of B round funding. That is, how do you get things actually into practice? And so unlike a lot of the other areas, I think a lot of partnering is needed to make those large-scale investments. It's very, very hard to build a $300 to $500 million demonstration project of a new technology with a single investor. And so I'm hoping that that is the type of dialogue that will start here as well. I know, Rick, you have a session this afternoon, right, on the commercialization. Is I hope that we have that kind of discussion as well, obviously a very robust technical discussion about that. So again, welcome. For those of you who came from, I said a couple came from the East Coast, welcome to our balmy June weather in Seattle. Actually, I got off the plane from Texas yesterday, and it felt so good to be back here after that. So it's now my great pleasure to introduce Candace Claiborne, who is the Dean of Engineering and Architecture, right? Architecture and Engineering at Washington State University, who also welcome you. Candace.
All right, well, thank you, Matt. Washington State University is also very pleased to join with the University of Washington today to welcome you to this symposium. The electric power industry is really important to the state and region, and obviously I don't really have to tell this group that, but I am proud to say that the research universities have played important roles to help develop the industry in this area. For Washington State University's part, we've always worked very closely with the electric power industry throughout its history. We did the early physical modeling of the Northwest dams in the early part of the last century. And when the Washington State aluminum industry pioneered the use of aluminum conductors for transmission lines, the expertise came from WSU. When microprocessors were used to protect the grid, the first installations were made in the Northwest by a young WSU professor named Ed Schweitzer, who's here today. So even to this day, WSU organizes the largest conference and the largest short course on power grid protection. So this is something that's very important to us still. Keeping in tradition with leading the technology, our power group, led by Professor Anjan Bose, it plays a big part in moving to the era of the smart grid. Anjan's technologies are used in control centers and grid operator training all over the world. And his colleagues have a number of other contributions to power, including middleware that is influencing the next generation of communication for the power grid, oscillation detection technology, and even the EPRI Red Book was edited by one of our faculty members. Our power program research includes a number of smart grid projects that are around the country, and we're involved in both the transmission level using PMUs and at the distribution level with smart meters. One project that we're particularly proud of is the Avista portion of the Northwest Demonstration Project, which is turning Pullman into a smart city and the WSU campus into a smart microgrid. We're also partnering with the University of Washington and the industry in Washington to create the Northwest Training Center to train the next generation of engineers to operate the grid of the future. I would like to say also that our efforts at WSU in the area of energy and sustainability are spread over all of the departments in our college and even beyond our college. They include a number of efforts in the areas of sustainable design, sustainable development, renewable bioenergy, and advanced materials. But our program in electrical power in the School of Electrical Engineering and Computer Science is one that's of particular strategic importance to the university. And this year we've added 3 new faculty members to the existing 6 in our power program. We're pleased to announce that among this new faculty is Professor Chen-Ching Liu, who is also internationally known for his contributions to the smart grid and who is probably known to many of you in the room because he started his career here in Seattle at University of Washington. So I'm sure it'll be noted today a number of times today, how Washington State is well positioned to lead the technological revolution in the smart grid. We're delighted to be part of the center that's being announced today to bring together the various strengths of academia, the government, and industry in the state to bear on this global issue. The Pacific Northwest is indeed well positioned to respond to an RFP should one be issued by the DOE around smart grid hubs. So thank you for being here today, and I hope everyone enjoys this very timely symposium. And now it's my pleasure to introduce our next speakers, Professors Daniel Kirshen and Anjan Bose. Daniel Kirshen joined the University of Washington in March of 2011. He comes from University of Manchester. Daniel holds the Close Professor of Electrical Engineering at University of Washington. In addition to his academic career, Daniel also has industry experience at Control Data Corporation and Siemens Empros, developing advanced application software for electric utilities. And Anjan, who I've already mentioned, is well known as a technical and an educational leader at Washington State University. He holds a distinguished professorship in power engineering and is the site director of the National Science Foundation-sponsored Power Systems Engineering Research Center. So please join me in welcoming Daniel and Anjan.
Thank you, Dean Claiborne, and thank you, Dean O'Donnell. I'll start talking, and Anjan will follow in a few minutes. When planning this meeting, we thought it would be good to start with a brief session talking about why we're here today. And I don't need to take very long with this audience to explain that there are enormous changes happening in the electrical energy scene. What's interesting is that we see a combination of a demand pull where lots of things are changing in the things that electric utilities have to do, like integrating more renewable energy, planning for the integration of electric vehicles, dealing with lots of assets that were installed in the 50s, 60s, if not earlier, and also the backlash coming from the fact that we have had a number of large blackouts. On the technology side, well, lots of new technologies are happening, wireless communications, sensors, in particular PMUs and smart meters, new forms of controls like flexible AC transmission systems or system integration protection schemes, and generally ubiquitous computing. So the pressure is also there to say, well, why don't you use those technologies to deliver electrical energy? So that led to the concept of what people call smart grid. And that's a very, very appealing concept with lots of interesting ideas that has led to lots of activities and certainly lots of talking about the world. But really, when you look at it, you think it needs a lot more definition. You know, how can we pull together all of these ideas to really do what a power grid is supposed to do, which is to be efficient, reliable, and also use less carbon than it does today. So what does this mean for Washington State? Well, first, it's a challenge. We also have to have this change in our power grid because it is also stressed. We've seen in the news recently the fact that some wind farms have to be curtailed because of the excess of water. That leads to tension, that leads to also technical problems in the grid. So Washington State and the utilities in Washington State need to develop a comprehensive solution that will continue providing the cheap, reliable, and green electricity that we enjoy these days. But it's also an opportunity, because if we look at our competitive advantages, we can see, well, can we try to work together, move fast, develop solutions, invent solutions in Washington State, and then sell them on to the rest of the world. So let's try to put this challenge and this opportunity together. And let's first look at what our competitive advantages are. First, we have electric utilities that have a tradition of innovation. Lots of technologies, as Dean Claiborne mentioned, were first installed in utilities in the Pacific Northwest. Utilities in the Pacific Northwest have led the way in integrating a considerable amount of renewables, and they have been doing a great job at energy efficiency and conservation. Another characteristic that I noticed very quickly as after I moved here is this cooperative planning process and cooperative operation that takes place amongst utilities in the Pacific Northwest, which has led them to realize that building more heavy infrastructure is not always the answer, and that those infrastructure should be combined with more IT infrastructure for monitoring, control, and decision-making, rather than spending a lot more money on heavy infrastructure that may not achieve the goal desired. Second competitive advantage that we have in this area is technology companies. We have a number of companies that provide technologies first to the power sector, like Schweitzer Engineering Lab, like Alstom, like Itron, companies that are world leaders in their field that already sell their products around the world. We also have a number of information technologies, such as Microsoft and Boeing, that develop technologies that are widely applicable and are also very interested in expanding their markets in electrical energy. And then we have this very vibrant energy sector startups. And I listed a few of them. I'm sure I have missed some because some of them are still quite small, but some of them will probably get very big within a few years. So those are also competitive advantages. Now, in terms of research, we also have some very, very strong institutions. We have Pacific Northwest National Lab that's been very active in various aspects of smart grids and leads in many of these aspects. And then we have our two universities, Washington State University and University of Washington. And as Dean Claiborne just mentioned, both of us have established programs in electrical energy and power systems. And both universities have been making substantial investment in new faculty members because we feel that this is an area that needs attention. Which leads me to the main reason we are here, which is the Washington Center for Electrical Energy Systems, which has already been shortened as being WACKES. And the idea is this center is a joint initiative from UW and WSU. And we already created a steering committee with representatives from industry and government to make sure that they keep us in the right direction. And our aim is to help develop a regional strategy for smart grids and to build on the expertise in system issues from power system issues and system issues in general from the two institutions. So, what are our plans? Well, as state institutions, we see it as part of our mission to provide a forum for non-commercial discussions on this topic. We believe that there's a lot to be gained if the utilities, the technology providers in the power sectors, the IT companies have a place where they can come and discuss issues, strategize together on how we can not only build a smart grid for the Pacific Northwest, but also use that technology as it is developed to sell it to the world. As state institutions, we can also provide neutral expertise on these issues to the decision makers. And we can also bring expertise from other fields into the discussions. Both of our universities have vast reservoirs of expertise in areas that are not currently active in the energy field, but could make a significant contribution to research in this area. Another important thing is that we want to help bridge the gap between energy and IT communities. When you go to some meetings about smart grid, you hear people from utilities talk about smart grids, you hear people from IT companies talk about smart grid, and they're using smart grid, but that's about the only word they have in common. So there is a huge gap that needs to be bridged if they can start talking the same language and moving forward in making things real. And finally, but certainly not least, we are looking at this center as a nucleus that can help lead research projects, large research projects involving research partners. And finally, we are education institutions, and our first mission is obviously to provide a suitably educated engineering workforce to all the companies that are active in this field. So at this point, I will leave the podium to my colleague Anjan Bose, who has already been introduced by Dean Claiborne.
Thank you, Daniel. Well, let me first add my welcome to all of you to take your day and attend the symposium. But I thought Daniel and I thought that this would be important to kind of get you all involved in this effort as we announce this start of the Washington Center. I think many of you in the room know me, and we've been working together on the power grid and the challenges here. And it's been a pleasure, of course, to work with this group of people in the Northwest who've been leading many of the efforts, actually, nationally and internationally in these areas. So as Daniel pointed out, we are recognized, in many of the efforts that are going on in this state are recognized as world leading. And in fact, this is also a very intense time in the area of smart grid. Many of you that I talked to this morning have been traveling somewhere else, and we just showed up here for this meeting and are about to go off again to somewhere else because we've got projects and ideas and things like that that are So we thought, Daniel and I thought that this would be a good forum to try and keep track of what people are doing in the Northwest and to try and have a neutral forum. Many of you are in very competitive industries. So here we are at an university in a neutral forum that for people to plan, people to think, people to put out ideas. I should point out that it's also a pleasure for me to welcome Daniel to the state. Because Daniel and I have had very, very parallel careers. He went to work, as you found out, with Control Data Corporation after his PhD. That's where I started as well after my PhD a few years before Daniel. And in fact, he worked in exactly the same group that was started, the R&D group that was started when I started with Control Data. That's, of course, a division of Siemens. And so it's kind of nice to have him. We've known each other for many, many years. To be colleagues again and working together here it's a great pleasure to do this. And but I wanted to point out that this cooperation between University of Washington and Washington State University in the area of energy, of course, didn't start with Daniel's coming here. I mean, we've been working together for a long, long time, and even though the impression is that we are always competing in football, there are many areas of cooperation like this, and I'll point out a couple of things that we're doing already. The one thing that was mentioned was the DOE Smart Grid Workforce Training Grant, and I think Mohammed El-Sharkawi is in this room right over there. He's the PI from University of Washington, and we've been working with all of the industries in the state of Washington to try and put this training together. Now, I'll put it in context a little bit. Again, when DOE announced $100 million worth of projects to start these training institutions or training centers all over the country, this was done not only for engineering, but also for technicians and also for companies, corporate kind of training. And out of the 100 million, 11 million came to the state of Washington in 3 projects. And the other projects that, the other 2, other than ours, that I already mentioned, one is run by Centralia Community College, which is a technician type training, 2-year training program, and the third one is run by Incremental Systems, which is in the area of power grid operator training. And so, in fact, there was a meeting of all these 52 different projects in Annapolis, Maryland last week, and all the 3 projects from here were represented. And one of the big questions was, how are these programs going to be sustainable after the $100 million runs out in 2 more years? And I can tell you that the state of Washington was much better prepared to answer that question than many of the other states. Well, the states were not represented directly, but all the different programs. And the reason is that in all of these 3 programs that is put up by the state, it's really being led by industry and not by the institutions. The institutions the educational institutions are developing the actual courses and the materials and all of that, but it is being led largely by industry in a big way. And that's what makes it sustainable. We have a big industry advisory board on our project that Mohammed and I have been so involved with, but several of the companies like Bonneville and Pacific Northwest Labs, Alstom, Incremental Systems are also involved in developing many of the materials that are going into the courses as well. So the other activity that both the universities are involved in is actually a much bigger activity. It's the DOE grant led by Battelle in smart grid demonstration. And this is the largest smart grid demonstration project that DOE is running. It's a $178 million project that has things going on in all these 5 states. Battelle, especially PNNL, is the lead institution, and there's about 12 regional utilities and BPA involved, 5 different vendors, and so on. But this is also the only demonstration project that has universities involved. And that's WSU and UW. So to give you an idea of what is happening in the 2 universities, the University of Washington is deploying a lot of advanced metering on campus. This is mainly to meter up buildings. So these are the smart buildings on campus, on this campus, that are being made smart by putting in a lot of advanced metering and monitoring. And then the whole campus then responds to a regional generation response to signals. The whole idea of having such a big 5-statewide project was to make sure that in times of trouble, in times of disturbances and so on, that people can actually have the communications between a lot of these partners to be able to respond with either curtailing load or increasing generation or things like that in a coordinated way. And that's actually being coordinated from the PNNL side. Our participation, as you heard Dean Claiborne mention, is rather exciting because those of you who know Pullman, Pullman is turning into a smart city, which means that every one of us who live there have a smart meter in their house. Actually, the smart metering part installation got started about 3 months ago, and it's already complete. So everybody in Pullman now has a smart meter already installed. And within a couple more months, I think the website's going to be set up so that every one of us can go to the web and find out what we did yesterday on ours in the house. But more than that, the university, which is, of course, as you can imagine, the largest customer for the power company in the town, is actually also putting in a lot of instrumentation on the 4 kV grid that we have inside the campus, and to make it more reliable and more monitorable, and and kind of operate that whole campus as a smart microgrid. Those of you, most of you are familiar with what a microgrid is, but essentially the reason the campus looks like a microgrid is because we also have captive generation. Now, we have about 3 megawatts, a little over 3 megawatts of generation, not counting the uninterruptible power supplies that we have in several buildings with critical experiments. So I think we're looking at, we also have a smart house on campus that looks at behavior of people and the correlation of that to electricity consumption. And we will also have in a few months large amounts of consumption data coming in through these smart meters that we have agreed with Avista to do some of the analysis on. This goes back to the data mining business of looking at how energy is being used and efficiency and reliability of that. So that gives you an idea of some of the things that we already have going together, and the idea of having the center is to grow on these kinds of cooperative ventures. I'll stop talking about the center here and talk about what we have planned for you today. First, of course, is the keynote speech from Patricia Hoffman, who's the Assistant Secretary for the Office of Electricity Delivery and Energy Reliability at the Department of Energy. And I'll introduce her in very soon here. Let me show you the rest of the agenda here. You also have it on the handouts that you picked up this morning. We have divided this up into about 3 sessions, and all of these sessions have very short presentations made by a couple of people, with the idea that most of the session will be spent in discussion from the audience, because the idea of getting all of you together is for us to get feedback from the community, from the power engineering community, from the electric energy community in this area, to try and come up with an agenda, an action agenda for this center that Daniel and I can take and run with over the next couple of years. So the first session that we have, we call it the vision session, and this is where we have Steve Klein who's the CEO of Snohomish PUD, and Mike Atkinson, who's the CEO of the Alstom Grid, to give you some feel for what we can do together. The next part is, the next session is on research, which is, of course, what we do here at the universities. And we have Carl Imhoff from PNNL and Daniel Kirshen from UW to put some ideas on the table, and then we can start discussing the research agenda. And then in the afternoon, we have this idea of how to go from research to commercialization. And Ed Schweitzer, the CEO of Schweitzer Engineering Labs, and Roger Sweet from the Washington Commerce Department will present their ideas of where this region is going in this area, and again, open to discussion. Finally, and that's about it. We'll like to Daniel and I will end up the day with a wrap-up session, which essentially says, tell us what you think we ought to be doing, given our discussions for the day. So having done that, let me introduce Patricia Hoffman. I think we're very, very fortunate to have Patricia Hoffman here. She's flown across the country. You may know there's a lot of stuff going on in Washington, D.C. right now about with smart grid. And in fact, day before yesterday, there was a big announcement out of the White House. You might have seen it in the newspapers and so on about smart grid. And I'm sure Patricia was probably busy trying to herd that thing through. But she is. Patricia is the Assistant Secretary for the Office of Electricity Delivery and Energy Reliability. I never can remember that long name for your office, Patricia, because we always know it as OE, right? So that's the Office of Electricity. And she's been very much instrumental then of all of the smart grid activities that has taken place since this administration has taken over, which is a lot. As you know, there's $4.5 billion worth of ARRA money that was handed out, and I'm sure, again, the supervision of that falls on Patricia's shoulders. So she provides the leadership on a national level to modernize the electric grid. Now, the OE, of course, started long before this administration came into place, and Patricia was actually in charge of the R&D side of that for a long time before she was made the Assistant Secretary, and she was really the Deputy Assistant Secretary and the Chief Operating Officer of this office for a while before she took over as Assistant Secretary. And as you can tell, she has been very much instrumental in trying to make sense out of all of this ARRA money and the stimulus and all of the jobs projects and so on, and turn that into real projects, technical, and define them technically as we move forward. She's an engineer. She has a Bachelor of Science and Master of Science in Ceramics Engineering from, I guess I don't. Penn State. Yes, that's right. It says there. So, thank you for coming all the way out here, Patricia.
Thank you very much. All right. I have a lot that I want to go over today, so I'll try to go through my slides quickly. What I wanted to do was continue to build upon some of the building blocks that have already been spoken about this morning, and really show you how all these pieces are starting to come together. It's a complex system, complex issues, complex regulatory structure, complex execution structure with respect to munis and IOUs. And so it makes it very difficult for somebody who's not in the business to get their hands around what we're trying to do here. And it is probably one of the greatest needs for the university community, the laboratory community, and industry to really pull together at this point in time, because we're at the beginning of the next evolution for the electric sector, and we have to do this right. We have to pull all the resources together that we have to make sure that we're building the system that's optimized, that's low cost, and that fits the needs of the regions across the United States. I would say the needs on the West Coast is different from the needs on the East Coast. There's different generation assets, there's different infrastructure involved. And what we need to do is continue to have more regional dialogues that really define the issues for the regions, the problems, and the solution sets. And the solution sets all come from both technology, markets, and policies. So as I continue to go through the presentation, I'm going to give you kind of insights on how all these layers either compound each other or help each other as we move forward. So starting off, technology, markets, and policies are just intricately linked. Policies drive markets, they drive technologies. There was mentioned earlier about there's the technology push and the demand that's being pulled. The thing that we need to look at is how do we fit all those pieces together? How do we make sure the regulatory and the policy aspects complement the engineering directions? How do we look at all those, and how do we evaluate risk as we move forward? We do things on the system knowing that we can say, okay, we'll go this far, but we're not sure exactly what may happen. As we move forward with wind integration, we're learning how to balance that wind integration, how we should transform, the business models around integrating wind on the system. How does that affect the environmental issues? And so there's a lot of things that come into play as we move forward. I have the first probably 6 slides as summary slides, and then I wanted to get into more technical depth in each of the different areas, but I wanted to at least, if I got cut off and Anjan said, time's up, I wanted to make sure I got several points across to everybody. Where we are heading is to advance grid functionality and flexibility. And what we want is to make sure that we're continually adapting our market, our regulatory infrastructure, our regulatory and policy world to the needs. What we are not doing is saying we're going to do a 30-year decision now, and that's going to be the decision for the next 30 years. If anything, we must be adaptable and flexible, that as we introduce technologies, we are keeping pace with the regulatory environment, the rate-making environment, the environmental environment, and other policies. The other thing is we have to push more security and resiliency in the electric sector, which means may go beyond some of the traditional business models that we're thinking about. How do we ensure that microgrids are complementary to the transmission system and the building of central station? So in the long term, how are we going to balance central and distributed networks or generation? So we're going to look at how do we optimize. So going on to generation, how do we optimize looking at synergistic technologies? How do we look at complementary technologies, natural gas being paired up with wind, nuclear being not so friendly to wind technologies? Making sure as we look at our generation portfolio, we do some thinking, we do some research to make sure that we're optimizing the mix and utilizing the generation that's available to us, as well as pairing it up with the transmission, but making sure that our goal is going after least cost, or at least, trying to make sure that we keep the cost of electricity low. Transmission, once again, using the transmission system for the best purpose possible. Looking at the mix of AC versus DC systems. How can we balance the use of both of those technologies as we continue to evolve our transmission infrastructure? How do we tap the renewable resources, the clean energy resources? How do we evolve that resource mix and use the next generation transmission system to support the needs of the future? At the distribution, there was some mention of electric vehicles. But how do we continue to evolve the distribution system to the needs of the future? I feel that there's a stronger need and a greater role of advancing that distribution system. And there is a huge opportunity there for a stronger role of the distribution system and the grid of the future. So how do we make sure that we have the controls, the algorithms, the insight, the measurement to make sure that distribution system can fit the needs of where we're heading. And then consumers, how are consumers going to play in all this, in the equation? One of the things that we need to look at is where should we be developing markets versus where should we be automating? A lot of people talk about, oh, we can have all the appliances and have a market revolved around consumer participation. I guess the question that I would ask is, where is it appropriate versus where should it be done in an automated fashion? So that there is an automated signal, there's a standard, it's done through automation versus everybody dialing a number to participate in the market. So impacts, one of the things we got to look at as we do that is keep in mind is how are we going to end up, what's the goal, what's the objective, what are we trying to achieve? We spent a lot of time looking at benefits and what are the benefits to consumers, what are the benefits to the system. As you look at a regional strategy, please keep in mind that we want to fine-tune some of the objectives and some of the benefits. As I talk about the smart grid, everybody's like, what's the killer application? And I said, it's going to evolve. It's going to depend on what time of the year we're talking about. I will tell you right now, there are a numerous amount of stories, good stories, that have come out of the value of the smart meter for restoration purposes as a result of the hurricanes, the tornadoes. Well, there wasn't any hurricanes yet, knock on wood. Tornadoes, but the bad weather that has come across the United States. Some utilities have been able to pre-position the restoration equipment or call them as they're coming down the road for mutual assistance and be able to tell them exactly where to go. They actually can map out where where the outages are and actually organize very quickly on how to restore the system and where to go. So that has been a huge insight and a great benefit. Now, as we get into the hot summer season, we're going to see, economic demand response. We're going to see peak load reduction. We're going to see a huge opportunity to utilize some of the sensing and information technologies, the smart grid technologies, for demand response. Workforce. Anjan mentioned the workforce. It's a key component to how we're going to have the key necessity for the future. We need to continue to build the workforce. We need to continue to evolve our courses with the universities, our training, to make sure that we have the skilled workforce that we need for the future. Manufacturing. Manufacturing is absolutely critical to continue to build the manufacturing and the supply chain base in the United States. Whether we're talking about transformers, if we really want to build a higher voltage 765 kV system, we need to have the components available to make sure that we can build that system. We also need to make sure that we have the control system components accessed and available. As we look at cybersecurity issues, as things impact the system, we need to make sure that we have the components available to restore and respond. So it really takes a hard look at, as we're doing a regional approach, to make sure there's the supply chain that's available in the local region. So really quickly, I'm going to go through the rest of these slides, focusing on transmission and generation. When I talk about the smart grid, smart grid to me is sensing, measurement, automation, control. But what we're really doing is, smart grid is only a platform as we evolve and modernize the whole electric system. So with respect to transmission and central generation, we're trying to really say, let's put our arms around this access to central renewable clean energy. Where are the resources? Where are the sensitive lands? What should be the transmission infrastructure? Let's build a logic structure. Heaven forbid we try to use logic, but a logic structure around where are the assets, how do we want to tap the assets, and what transmission system will maximize that penetration in those resources. So we've done some different maps looking at the availability of resources and what the transmission potential connection points would be. I've talked about this. It's more of a balanced approach. We're trying to go after how do we make sure some of the transmission the generation technologies are synergistic. At the distribution level, bringing in more technologies at the distribution levels, but looking for opportunities for reuse, really even combining thermal as well as electrical management. So looking at hybrid energy systems. At the distribution system, there's a huge opportunity here for this to evolve. But one of the things we need to look at is what is the business model for the utility? What is the role of the utility? Are they going to be a neutral party to help assess some of the insight that some of the utilities are, as people have been wondering where they've had strange consumption patterns that they didn't understand before. And the utility would work with the consumer and find out that a piece of equipment was installed improperly and it was having a huge draw at a strange time of the day. So there's been a lot of insight there. As we develop new technologies, the vehicles, how do we want to continue to evolve the distribution system? Volt-VAR has always been known. It's been known for, wow, we can do a lot with voltage reduction. So there's now some data and some better engineering analysis that's behind it to show where the value is and where one can take advantage of this. Being able to reroute power, to be able to restore quickly, that's another opportunity. Automation on demand response is a huge opportunity. As we look at engaging the consumers, the question I keep asking is when is it appropriate to engage the consumer? What level, given the tolerance level for consumers? I tell most people my mom ain't going to want to play with her equipment very much, whereas my 20-year-old loves to play with everything and loves to do the apps and the cool things. And we got to tailor products to make sure that we meet the needs of the consumers. So once again, energy management, how can we push this to the next generation? How can we look at buildings to say, let's look at some different optimization, whether the conference room is occupied or unoccupied. Let's look at more sophistication that we can do in providing and managing our profile with respect to buildings. Understanding consumer behavior, psychology. I was out at Case Western and a couple other universities and kind of appealed that we really need to understand the psyche of the consumer on how we can best tailor applications, but also understand where we can get the results that we hope to get, and then provide that feedback to the regulatory environment so that as we're developing rate designs, we're truly achieving what we hope to achieve. We're not getting a flashback. We're not getting something that was unintended consequences. So be flexible as we look at multiple rate design offerings to say, is this being effective? If our goal is to reduce peak load by 10%, is the rate design achieving that purpose? If our goal is to help manage the rollout of electric vehicles with a time of use rate, are we actually getting what we hoped when we implemented that type of design? So we have a lot of consumer behavior studies trying to pair up with some of the policy objectives to make sure that what we're designing is actually achieving the purpose. So some research opportunities, just really quick. I broke it up into two categories. Where I'm heading is the communications and controls kind of opportunities, and then the technology and the hardware type opportunities. We have a lot of data coming in. Now, how can we best utilize that data? What are the information requirements? What are the network requirements? What is required on the system to best utilize the data? Also, what type of control do we want to have where? Can we do more distributed control versus central control? How do we really maximize the architecture? Those are some of the questions that we need to ask. And at the end of the presentation, I'll hit you again, security, security, security. Let's make sure that as we look at this architecture, look at these components, we include security. The research areas is looking across the whole spatial temporal dimension, looking at from what we're looking at from seconds all the way to the transmission planning. We're trying to really pull a lot of that analysis together so we can actually go across the spectrum of saying, if we really want to look at 5-minute markets, and how does that build out? So what we need to do is actually look at that from a more holistic point of view. Improving situational awareness through the Synchronous Phasers. It's a huge opportunity to provide real-time data into the control and operations of the system. So how do we continue to evolve that capability so we can actually maximize the use of this technology? We do a lot of modeling, but what we really want to do is marry the use of sensors and data and real-time data on the system to how we're looking at modeling. So from the technology's point of view, power electronics, really key. Advanced technologies, transformers, protection devices, storage. Storage is a huge opportunity. Energy storage, the only thing I guess I'd like to say at energy storage is sometimes used too broadly. What we're talking about is storage technologies for regulation, for ramping type technologies. So you're looking at ramping with the wind and you're talking energy management. I would like the conversation to evolve specifically when we're talking about energy storage for the type of service that it's trying to provide. So we actually can move that dialogue further. What we're trying to define is the value and benefits of energy storage as we look at how do we, compensate for those benefits on the system. So is it a system asset? Is it a generation asset? What type of service is it providing? So one of the things, and what is the cost requirement or the penetration capability based on that? So those are some of the things that we're trying to do in evolving the energy storage discussion. I just want to close with security and risk. As any sector introduces new technology, we got to keep in mind, especially in information control-based technology, we've got to keep in mind the security and risk components to that. And what it is we can introduce vulnerabilities if we're not careful. So what we need to do is make sure that we're analyzing any potential security and risk. It goes just like the banking system introduced wonderful function and capability with online banking. Well, there's also the concern, the flip side of it. So as the electric sector kind of parallels and starts introducing more function and capability, we just must maintain diligence and awareness for security. It is not a one-time fix. I call security more of a service, something that we need to keep in mind constantly. We must have diligence. Also, we can go too far. As you look at your house, you can put a lock on your door, you can put a security system in. There's different levels of security with different risk that one would expect to have for a system. So we need to have an evaluation of the cost versus risk equation as we look at security on the system. So just many things out there, especially at Congress, that we're trying to be pushed against, whether it's blackouts, geomagnetic storms, cybersecurity issues. What is the expectations? That's where the conversation's driving. How much protection do we need, at what cost, and what level of risk are we willing to accept? For the most part, the electric sector is when a hurricane comes through, we rebuild the system. It's a general expectation that if the lines and the poles go down, we'll just rebuild it. My perception now is that this expectation is changing and that people want more reliability, they want less rebuilding of the system, and I think we need to make sure that we have the debate out there to what is the expectations and what are the cost implications as we move forward. With respect to security, the issues are evolving. The threats are evolving. We're going to learn more there, but we need to keep pace with what we need to be prepared for.